Good morning and welcome to Weather Academy. I'm meteorologist Tom Atkins. Today, appropriately so, we're going to talk about lake effect snow. You know, we hit the first day of December yesterday and we got a true snow belt lake effect snow. So let's talk about the process and some interesting things that happen. The setup is this. You need warm air below. You need cold air to come across that warm air above. In fact, what you need is about a 23-degree Fahrenheit temperature difference between the lake water temperature, which is right now about 46 degrees, and the air temperature going about 1 mile above that lake. So say it's 23 degrees coming from Canada, you got a 46-degree lake, you get enough of what's called instability to make that air rise. So again, what you have is air coming across, and what happens is when you have warm air, it usually seeks a higher level. So it's going to try to rise as it comes across. And as air rises, it will form clouds. And if you keep that situation going, clouds will form precipitation. And that's lake effect in a real small sense. Now it gets more complicated when those lake effect clouds and lake effect snow bands start to go over land. And in our case, another interesting thing happens. It not only drops snow showers along the lakeshore, but as you rise in elevation up the I-90 ridge, it gets even more efficient at producing lake effect snow squalls, which is why the areas south and east of 90, called the snow belt, usually get more than the lakeshore. Another thing that inhibits heavy snow along the lakeshore, especially at this time of year, and that's what happened here in the last 24 hours, is that 46-degree water temperature. With the wind blowing off the lake close to the lakeshore where the city of Erie, the Route 5 corridor, is located, you get some warming. So you can't drop the temperatures below freezing to get the good accumulations like you can as you raise the air up the I-90 ridge and over it into the snow belt. So let's talk about the Great Lakes in general, then we'll hone on in to our local area. Lake effect, of course, possible across all 5 Great Lakes. Interesting fact here, Erie is the shallowest lake. So that has the most potential to freeze during a cold winter, and that can cut down somewhat on your lake effect. But Lake Ontario, much deeper. In fact, one of the best snow records for 24 hours of snow in the United States happened in 1997 on what they call the Tug Hill Plateau east of Lake Ontario. 76 inches in 24 hours. That's 3 inches per hour for a full day from lake effect off a lake that doesn't freeze. And of course, Huron is bigger than that, Michigan and Superior bigger than that. So you've got these kind of favored areas where the wind comes from Canada, blows over the warmer waters, and drops the lake effect to the lee or east side of the lakes. But let's bring it home to what we're used to here. Lake effect also depends on the wind direction. Now, if you have a southwest wind, that is over what we call the axis, the long axis of the lake. In other words, it's got a lot of water to work with to lift into those clouds, pardon me, and produce the lake effect snow bands. So when you have a southwest wind along Lake Erie, it's along what we call fetch, and that's the distance the air travels over the water, and it shuffles off the snow into Buffalo, keeps it north of Erie, and that's when they get their huge lake effect events. Now, when the winds start to shift a little bit more, maybe west or a little west-southwest, it brings those bands across Erie County up into ski country in New York. And this west-southwest flow is what happened with the Christmas storm. It stayed steady state and just sat over us for a couple of days, producing that heavy lake effect event of 2017. Finally, the way the snow belt gets the snow is the northwest flow. Now, the interesting thing about that is it can involve 2 lakes, not only Lake Erie, but also Lake Huron. So you have kind of a double fetch here, and with the rising of the I-90 ridge making more efficient snow squalls, that's why most of the snow with the northwest flow occurs south and east of 90, and that's where they have the heavier amounts in this particular situation. I took a little drive a couple nights ago, and we're going to talk about elevation just a little bit here. I went down to the Route 5 corridor. This is East Lake Road in Harbor Creek. This is a lake effect scenario here. You can see the snow falling, but you can kind of see it melting as it hits and not accumulating on the ground. That's because of the 46-degree lake. About a mile to the north, this is about the Route 20 corridor. This is by the East Side YMCA in Harbor Creek. You see it starting to frost the ground. You're up a little bit in elevation, so you're getting a little better accumulation. Up here, right about 38th Street, Cooper Road, the Gorge, now you're even higher in elevation, so the same lake effect band is starting to stick to the roads there because you're getting a little cooler as you go up. One more notch up Station Road. This is Penn State Barron. Not only is it accumulating on the grass, it's accumulating on the roads here, and it's starting to pile up a bit on the curb. Finally, you get up to that I-90 ridge. This is by the Get-Go station at the Harbor Creek exit, and you can see it very easily accumulating on the road as well as starting to cover the grass. So that's the elevation angle to our lake effect snow in Erie County. The higher you go, the more you get snow. Well, I hope you've enjoyed this segment. One of our meteorologists will be back next week with more Weather Academy. Make it a great rest of the week.